Assalamu alaikum students, can you hear me? Okay, so we will continue the last worksheet that I sent. We were discussing the projectile motion, right? We have discussed the projectile motion, and how many questions we have done? We completed 3.1, right? Page number 3 of the worksheet, right? Page number 3. Can you hear me? Only one question, right? So we will start from question number 3.2. Everybody can hear me clearly, right? And the screen is clear, right? Are you able to read? Tell me, okay, when I'm writing. So we are discussing in this worksheet we are discussing EOT question number 11 and question number 18, right? EOT question number 11 and question number 18. These questions are from the topic projectile motion. Question number 3.2 from the worksheet, question number 3.2, page number 3, right? Page number 3 of the worksheet. A projectile is launched from the top of a building with an initial velocity of 30 meters per second. So here a projectile is launched from the top of a building with an initial velocity of 30 meters per second. This is the building. At an angle of 60 degrees above the horizontal. So here we are drawing the projectile. So this projectile is launched from the top of this building. So this projectile will follow this path. So this is launched from the top of the building with an angle of 60 degrees from the horizontal. Angle 60 degrees above the horizontal. The magnitude of its velocity at t equal to 5 seconds after the launch. So we need to calculate the magnitude of its velocity after 5 seconds. Okay, the question is calculate the velocity. Calculate velocity after 5 seconds. Okay, so this is the starting point. Here the time is 0. After 5 seconds the projectile will be anywhere here, right? The projectile will be anywhere on this path. We do not know the location. So when the projectile is here, at any point the projectile will have both horizontal velocity and vertical velocity. So we need to calculate the velocity of the projectile. Just for example, after 5 seconds the projectile is here. So the projectile will have horizontal velocity and vertical velocity. At maximum height, right? Okay, so this is at not maximum height. Okay, I will draw here. After 5 seconds the projectile is here. So this projectile will have horizontal velocity Vx and vertical velocity, that is Vy. So what is the velocity of the projectile after 5 seconds or at this point, velocity of the projectile at that point, that is equal to Vx plus Vy, right? You have studied a vector, that is why I used a vector notation. If it is confusing, then I will just remove that. Okay, Vx plus Vy. Okay, keep it, because if I draw that is not correct. Yeah, we will draw the vector. Yes. So what is Vx? So if you know the Vx and Vy, after 5 seconds, you can easily calculate the resultant velocity. Okay. So what is Vx? After 5 seconds, right? So I will write V final x. That is equal to how much? Very good. Perfect. Vi cos theta. What is Vi? A projectile is launched from the top of a building with an initial velocity of 30 meter per second. That is given in the question, right? 30 meter per second. So Vx, the horizontal component of the initial velocity, that is always 30 cos angle 60 degree. Okay, so we know that the velocity along the horizontal direction is always constant for the projectile. Vix, that is initial velocity in the x direction, and the final velocity in the x direction, same, right? Same. So final velocity in the x direction, that is equal to 30 multiplied cos 60. So we got the Vx. We know the value of Vx, 30 multiplied cos 60. So I think this is 1.5 meter, 15 meter per second. Can you check? Is it 15 meter per second? Okay. The next Vy. Vy, there is acceleration in the y direction, right? There is acceleration in the y direction. Final velocity along y direction, we can calculate that using the equation. Final velocity along y direction, that is equal to initial velocity along y direction plus acceleration along the y direction multiplied time taken. That is equal to, what is the initial velocity along the y direction? Initial velocity along the y direction, that is equal to 30 sine 60. So initial velocity along the y direction, I will write 30 sine 60 plus acceleration, that is always minus 9.8, because acceleration due to gravity for projectile motion, acceleration is always minus 9.8 into time. Time is 5 seconds, which equals 30 multiplied sine 60 minus 9.8 into 5. 30 multiplied sine 60 minus 9.8 multiplied 5. Students, is the answer is 23 meter per second, right? 23 meter per second. We know the velocity along the final velocity along the x direction, final velocity along the y direction. So what is the resultant final velocity? This is the resultant final velocity. We know Vx and Vy. So how to calculate the magnitude of the final velocity? Final velocity equal to square root of V final velocity along the x direction square plus V final velocity along the y direction square. that is equal to, if you don't see what I am writing here, no problem, I will just substitute these values here. 15 square plus 23 square. So the answer will be square root of 15 square plus 23 square, that is equal to 27.5. Yes, I also got negative 23. Okay, I also got negative 23, no problem. So here the answer is 27.5 meter per second, right? So this is negative 23. It should be negative, right? Because here you can see Vy is in the downward direction. Okay, so when we means apply my negative 23 here, negative 23 is squared, right? Yes. Okay, what's your question? I will like maximum 5 minutes. Okay, we will take the questions, then we will move to the next. So you can ask if there is any doubt for this question. This one, right? Yes, that's correct. I didn't understand your question. Yeah, for acceleration, it is always minus 9.8 for projectile motion, because it is acceleration due to gravity, because acceleration is in the downward direction. See, upward direction is positive, downward direction negative. Okay, I understand what you are telling, because it is falling, right? So when it is falling, velocity is increasing. That is why velocity is increasing. That is why you are telling acceleration should be positive, right? Because the object is moving and acceleration, both are in the same direction, right? Okay, so forget about that. Then think like this: downward direction is negative, upward direction is positive. See, when velocity is in the downward direction and you calculated the velocity, here you got the negative value, right? Yes, like, yeah, I can explain this, but when I explain, you feel it more complicated. Okay, because when velocity is increasing, the negative value will be increasing, right? Negative value will be increasing, and when we calculate acceleration, still we will get acceleration as negative. Okay, so any other question? Yes. Okay, that's a good question. Okay, 1 minute. Okay, what was the first question? Okay, we are not using different equation. Okay, we are actually using the same equation. See, v x final, right? V final along the x direction, right? Equal to, I am using the same equation. Okay, v final along the x direction is equal to v initial along the x direction plus acceleration along the x direction into t. Okay, v final along the x direction is equal to v initial along the x direction plus what is the acceleration along the x direction? Acceleration of a projectile along the x direction. Yes, acceleration of the projectile along the x direction is equal to 0 because horizontal velocity or velocity along the horizontal direction, that is velocity along the x direction, is always constant. So acceleration is equal to 0. 0 multiplied time, what is 0 multiplied times 0, right? So I am not writing. Should I write 0? No need, right? I am not writing 0. So what is V final along the x direction? V final along the x direction is equal to V initial along the x direction. What is V initial along the x direction? V initial along the x direction is 30 cos 60. 30 multiplied cos 60. So I answered the first question. What was your second question? Is it clear, student? Always. In a projectile motion, always. Okay. In the question, if there is projectile, like an object is thrown at an angle, anything, acceleration along the horizontal direction is always 0 for a projectile motion. Anything else? That's a good question. So these are two different questions, okay? Both are different situation. So in the first question, you are on the top of a building and you are throwing like this. You are throwing like this. You are throwing in the horizontal direction. Can you imagine that? You are standing on a building and you are throwing in the horizontal direction. Yeah, 0 degree, yes, 0 degree, okay, along the horizontal. So angle is 0. In the second question, what you are doing, you are in the top of the building and you are throwing like this, okay, you are throwing at an angle. So that is the difference in the question. I hope you understand. Okay, we will move to the next question. We will finish this worksheet today. Okay, question number 3.4. I will erase this. Okay, students. Question number 3.4. During practice, two baseball outfielders throw a ball to the shortstop, anything. In both cases, the distance is 40 meter. Outfielder 1 throw the ball with an initial speed of 20 meter per second. Outfielder 2 throw the ball with an initial speed of 30 meter per second. In both the cases, balls are thrown and caught at the same height above the ground. So we have two situations. Number 1, number 2. In the first one, ball is thrown like this at a speed of 20 meter per second. 20 meter per second. In the second one, same height, same distance, everything same. Ball is thrown at 30 meter per second. Which one will reach faster to this side? Second one will reach faster. Which one will stay more time in the air? Yeah, the first one will be more time, will take more time in the air. So what will be the answer? Ball 1 is in the air for a shorter time than ball 2. Ball 2 is in the air for shorter time than ball 1. B is correct one. B is Correct one. This is a direct question, just a common sense question. If you throw faster, it will reach faster, right? Yes. What is C? Both the balls are in the air for, no, not C. Because when you throw it faster, it will reach faster, right? Because both are taking same. For example, this is a this is 50 meter. 50 is too much. Okay, 30 meter. 30 meter. Okay, 30 meter. So same distance need to travel. Then when you, like, for example, you want to walk 30 meter. If you walk faster, it will take less time, right? If you walk slowly, it will take more time. Correct? Okay, that's all. I hope you understand. Any questions, students, about that? The answer cannot be decided from the information given. No, that is not correct. Why? In both the cases, ball are thrown and caught. Maybe different question. Okay. For example, maybe she gave a question like this. This question they may ask in the exam, and I think this question is not in the worksheet and in the Heikel. So just we will explain that. Okay, you are on the top of the building here. What are you doing? You are throwing a ball with a speed. For example, you are throwing a speed 30 meter per second. The ball will go down like this, right? Okay, so this is the ground. And what you are doing at the same time, or another ball, you are just dropping the ball without any initial velocity. You are dropping the ball. Which one will take more time to reach the ground? No. In this case, both will take same time to reach the ground. Because this is the vertical distance, right? No. What is the, for example, when you drop an object, okay, you are not throwing down. You are not throwing down. You are just dropping it. Okay, you are dropping the object. You are dropping the ball. So when you drop the ball, what is the initial velocity along the y direction? When you drop the ball, when you drop an object, what is the initial velocity? Not final velocity. When you drop, how many times I was telling this in grade 9? When you drop, the initial velocity is 0, right? 0. Okay. When you throw horizontally, like this you are throwing, in that case also, what is the initial velocity along the vertical direction? Student, 0, right? Because you are throwing it horizontally, right? You are throwing the ball horizontally, so you are not throwing vertical direction. So initial velocity along the vertical direction is 0, both case. Okay, so if you, I don't want to spend more time on it, I will just tell like this. I am standing on the top of a building. Okay, I am standing on the top of a building. This marker I am dropping, and this marker I am throwing in the horizontal direction, not throwing up, no, throwing in the horizontal direction. So both will reach the ground at the same time. About what? No, 30 is nothing. Just I have given, like, suppose we are throwing at an angle 30. Okay, just I gave a number. Nothing. Okay. Then next 3.6. Question number 3.6. You can read the question, students. You can read the question. You mark your answer. Okay, you mark the answer. When I tell the answer, you can check whether the answer you marked correct or not. For a given initial speed of an ideal projectile, there are launch angles for which the range of the projectile is the same. Only one, two different angles, more than two but a finite number, only one if the angle is 45 degree, but otherwise two different angle, an infinite number of angles. What's your answer? I think some students are telling the answer B. Okay. My answer is D. I want to take this answer because we are launching the projectile. For example, if I launch at an angle of 30 degree, okay, I am getting this horizontal distance. Then what is the another angle for the 90 minus 30, right? What is 90 minus 30? 90 minus 30, 60. Okay, for 60 degree and for 30 degree we are getting same distance. Okay, but if I throw the ball at an angle of 45 degree, I am throwing this ball at an angle of 45 degree, so it will travel the maximum distance. Then what is the this is 45 degree, what is the next angle for which I will get the same distance, for which the projectile 90 minus 45, right? What is 90 minus 45? 45. So if the angle is 45 degree, we have only one angle, right? 90 minus 45, same, right? Okay, so answer is D, only one if the angle is 45 degree, but otherwise two different angles. Amina, this is a very simple question. Okay, very simple question. Just think it is very simple first. Okay, very simple. Then slowly read the question again and check, are you able to understand that? Yeah, two different angle, we will get same horizontal distance. Okay, the projectile will travel same distance for two different angles. I will write like that. A projectile, any projectile, okay, a projectile, you know the meaning of projectile, right? Projectile is any object that you are throwing. If you take a plate, throw it, that is a projectile. If you throw your pen, that is a projectile. If you throw your shoes, that is a projectile. If you throw a ball, projectile. So projectile is anything that you are throwing. A projectile, but when we say projectile, it means something different that is not familiar to us, right? But very familiar. We took a paper ball, throw the paper ball. Very familiar, very common. A projectile, what did I say? A projectile travel, right? A projectile travel same distance. A projectile travel or cover same distance for two different angles. So what are those two different angles? Theta and 90 minus theta, correct? Theta and 90 minus theta. For example, if you throw the projectile at an angle of 10 degree, it will travel a distance, and it will travel the same distance if you throw the projectile with another angle. What is that angle? 90 minus 10. 90 minus 10 is 80. Okay. Then if you throw the projectile at an angle of 20 degree and it will travel a distance, the projectile will travel same distance at what angle? 70 degree. So we will make it a little bit better. One more information I will add here. Okay. For example, for 10 degree, it is traveling a distance of 30 meter. Okay, 30 meter. And for another angle, right, 80 degree also it will travel same distance. Okay, same distance. So here I will write angle, here I will write distance. Okay, yeah, okay. Angle and distance. Okay. Huh? What is the meaning of 180? 180 means you are turning this side and throwing to the other side, right? Okay, so we will take as same angle but other direction. Okay, it is not necessary to take like this, right? If you throw to the left side, we will not change the angle. Okay, from there we will measure 90. Okay, then angle, okay, 10 degree I said, right? At 10 degree, what is the distance traveled? For example, 30 meter. Okay, then another angle, it will travel the same distance that you said, it is 90 minus 10, that is equal to 80, right? Okay, then 20 degree, what distance will it travel? What distance will it travel? Will it travel again 30 or less than 30 or more than 30? Huh? Less than 30 or more than 30? Tell me. When you increase the angle of a projectile, it will travel more distance. Okay, when you increase the angle, it will travel more distance. So it will travel, for example, it is traveling a distance of 40 meter. I am giving just examples. Okay, numbers are not correct. 20, then what another angle the projectile will travel the same distance? Another angle. Huh? Yeah, 90 minus 20, 70. For 70 also it will travel the same distance. Okay, the next thing, 30 degree, it is traveling a distance of 50 meter. What is the, at what angle? Very good. How did you get a 60? 90 minus 30. Very good. Next, students, we are throwing at an angle of 45 degree. It is traveling a distance of 60 meter. Okay, 60 meter. We are throwing it at the same speed. Okay, speed we are not changing. I am throwing it with the same strength. Okay, at what angle, at what another angle the projectile will travel the same distance? Again 45, right? Okay, same angle, right? So at 45 degree there is only one angle. The next day you are throwing at an angle of 50 degree. 50 degree, right? Okay, 50 degree. Will the projectile travel a distance more than 60 or less than 60? Less than 60, right? So here I will write 55 meter. Okay, how less? Because a projectile will travel maximum distance at 45 degree. A projectile will travel maximum distance when angle theta equal to 45 degree. Below 45 or above 45, the distance traveled will be less than that. At what angle, students listen here, at what angle the projectile will travel maximum distance? 45 degree. If it is above 45 or below 45, if it is greater than 45 or less than 45, what about the distance traveled? Yeah, yes, so it will be less, right? Okay, so here our answer is D. I hope you understand. Then we will discuss question number 3.11. Yes, students, any question? Yeah, 3.10 will come after 3.11. Okay, to to adjust the space, I did it like that. 3.11. In ideal projectile motion, the velocity and acceleration of the projectile at a maximum height are respectively horizontal and vertical downward, 0 vertical downward, horizontal 0, 0 horizontal, 0 0. All of you mark your answer. Okay, just to mark your answer, and after we complete the discussion, you can check whether your answer same as we have discussed or not. So we will draw the projectile motion like this. Okay, so you know that, right? At a maximum height or at any point, what is the direction of the acceleration? 0 at any point. Downward, right? Acceleration is always 9.8 downward direction. Same length, it should be same length. Okay, acceleration is always 9.8 in the downward direction. So this is the direction of the acceleration. At a maximum height, students, what is the value of the velocity along the vertical direction? What is the value of Vy? At a maximum height, vertical velocity is always 0. At a maximum height, what is the value of the horizontal velocity? Yeah, horizontal, very good. Vi cos theta means horizontal velocity always constant, right? Horizontal velocity Vx always constant. Vx is always constant. At the maximum height, there is only one velocity, right? Only velocity along the x direction. There is no velocity along the y direction. So you can see at the maximum height, velocity is horizontal and acceleration is vertical downward. How many of you mark the answer A? Yes, A is correct. Very good. That you must know, because they said the maximum height, right? That is why they said the maximum height. That you should know. Whenever there is maximum height, the next point should come to your mind. Yes, vertical velocity 0, velocity only horizontal. Okay. Answer A. Velocity in the horizontal direction, acceleration downward. Why we didn't choose D? Because velocity is not 0, right? How velocity can be 0? D you said, right? D 0 and vertical downward, right? Velocity cannot be 0 because it is moving, right? At maximum it is 0 when that if you throw like this, if you throw straightly up, okay. No, see, in the question it is said in an ideal projectile motion, right? What is projectile motion? Projectile motion has horizontal motion and vertical motion. This is not projectile motion, it has only vertical motion, right? If you throw straight up in the air, it has only vertical motion, it is not moving in the horizontal direction. A projectile has both horizontal motion and vertical motion. Vx, what is means? The value? Here we don't have any value, right? Here we do not have any value, but in any projectile motion, Vx will be always Vi cos theta. This angle is theta, and the velocity when you are throwing the object, if you are kicking a football, then at the time you kick the ball, you are giving a velocity to the ball, right? That is the initial velocity Vi. Yes, only y component is 0 and x component is always same, no change in the x component. For example, at the time when you kick the ball, if the x velocity, okay, velocity along the x direction is 2 meter per second, always 2 meter per second, okay. Vx is 2 meter per second, here 2 meter per second, here 2 meter per second, here also 2 meter per second, here also 2 meter per second throughout the motion. Enough. Okay, slowly read question number 310. Okay, I will connect my charger to the laptop. All of you read the question number 3.10 and mark your answer. A baseball is launched from the bat at an angle 30 degree respectively to positive x-axis and with an initial speed of 40 meter per second, and it is caught at the same height from which it was hit, assuming ideal projectile motion, positive y-axis upward. The velocity of the ball when it is caught is, okay. Do you play baseball? No, right? Because this book is based on America, I think baseball is common there. That is why they put baseball. Huh? I thought there is no time to play baseball. What did you say? No need of time. No need of time. Same height, right? Yes. Yeah, I understand your question. Okay. You are throwing the baseball to too much. Okay. At what speed? 40 meter per second, right? So initial speed is 40 meter per second, and what angle? 30 degree, right? 30 degree. It is caught at the same height, right? At the same height. Assuming ideal projectile motion. What is the meaning of ideal? Perfect. No air resistance. Correct? What is projectile? What is ideal projectile motion? In an ideal projectile motion, a projectile has horizontal motion and vertical motion. Number one. Number two, what is the only force acting on the projectile? Force of gravity. And is there any air resistance? In ideal projectile motion, no air resistance, which means no energy is lost, right? No energy is lost. So what is Vx? Vx is equal to, tell me, Vx initial, okay? I will write Vix. Vfx. Okay, yeah, 40 cos 30, right? Okay, how much it is? 34.64, right? 64. So in which direction? Along this direction, correct? Okay, so 34.64 meter per second along this direction. What will be the direction of the vertical velocity when you catch the ball? Not when you throw the ball. Okay, when you throw the ball, it is upward, right? Vertical component. When you catch the ball, what is the direction of the downward, right? Correct? Vy is downward. Will it be positive or negative? Negative. Okay, I think you got the answer, right? Okay, value I didn't calculate for Vy. Okay, so how to calculate for final velocity along the y direction? That is equal to, yeah, 40 multiplied sine 30, so 20, right? 20 meter per second. It is in the downward direction, so minus 20. Okay, downward direction. Yes. Yes, here we did not use the equation, right? Okay, so yeah, I will tell you. Wait, okay, can you wait for 1 minute? Okay, you will get the answer. For example, initial, what is the initial velocity? Initial velocity along the y direction? 20, right? Correct? 20 meter per second. When it is moving up, will it be greater than 20 or less than 20? Less than 20. When it is moving up, when a projectile is moving up, vertical velocity will be decreasing. So we will write 15. Okay, just examples. Okay, again continuing. Less than 20, less than 15, right? I will write 10. Yeah, means vertical velocity or velocity in y direction. Okay, so I will write Vy. What is the meaning of Vy? Velocity in vertical direction is decreasing. This I have given in the table. Okay, in the first table of projectile motion I have given this. Vy is decreasing while moving up. Okay, Vy is 0 when at maximum height. Vy is increasing while falling. Okay, I can add one more thing here. Vy is decreasing, or Vy is positive and decreasing, right? While moving up, I will add one more point here. Vy is positive, correct, students? Vy is upward, right? Upward is positive. Vy is positive and decreasing while moving up. Vy is 0 at a maximum height. Vy is, can you add one more point here? What should I write? Very good. Negative and increasing while falling. Okay, so here 5 meter per second. Okay, at a maximum height 0. We are drawing only Vy. Okay, if I draw Vx we will draw after this. Okay, from here what is happening to Vy? Now increasing. Okay, negative 5, increasing, negative 10, negative 15. Okay, so we reached here, negative 20. Okay, so it will not lose its velocity. The projectile will not lose its velocity. It will not, means it will not lose its energy. Okay, what is happening? You studied conservation of energy, right? When it is moving up, what is happening? Velocity decreasing, right? Velocity decreasing means kinetic energy decreasing. When it is moving up, what is happening to the height? Height from the ground. Height increasing. When height increase, what happens to the potential energy? Potential energy increase, right? So decrease in potential energy, decrease in kinetic energy equal to increase in potential energy. When it reach here, when it start from here, potential energy 0, it has only kinetic energy. When it reach here, again its potential energy is 0, it has only kinetic energy. In an ideal motion, no energy is lost. The kinetic energy when it is starting and kinetic energy when it reach here same, which means it has same speed. Yes. Yeah, V final x component and V final y component also. Okay, yes, correct. Okay, but there is a condition given. It is at the same height. Okay, height is same. The height, you are throwing the ball from this height and catching the ball also at the same height. Okay, that is a condition. Okay, then next we have why negative? Negative only one reason. Okay, keep it in mind. Negative is because of only one reason. What is the one reason? Direction downward. Okay, now you will not forget, I hope. Okay, question number 3.4. A football is kicked with an initial speed of 27.5 meter per second and a launch angle 56.7 degree. What is its hang time? The time until it hit the ground. Yes, recording. Okay, students, there are two more questions. You can do one thing, you can do those questions and I will explain these two questions in the next class. Okay, because I have to start class for grade 10. Okay, so you can solve this question your own, and we will discuss the question next class. Yes. 3.27, 3.29 are not projectile motion, right? That is vectors. Okay, we will discuss that when we are discussing vectors, maybe in the next class. Okay, thank you students for joining the class. See you tomorrow. I will end the meeting.